So let's pick up at the point that we left off. Up to this point, we've talked about how we're going to have arteries, veins, capillaries. Mentioned quite a bit about that capillary bed and how that is our business end. So the next part that we're going to look at is going to be about the wall of these vessels. The wall of the arteries, the veins, and the capillaries. And like I kept mentioning on Tuesday, most everything that we have covered, all right, part one, part two, we've always had 3 layers. We've always had an inner layer, outer layer, and a middle layer. Same principle is going to apply for our blood vessels. So the difference is we've got some pretty cool names for them. When we look at the vessel walls, the one that is the innermost wall, tunica, oh man, I have a spelling error right there, okay? So y'all make sure to put tunica, T-U-N-I-C-A, all right? Tunica interna, also known as the intima. But now take the term apart, okay? Tunica. What does it make you think about? A tunic, okay? When I think about a tunic, I think about a wrapping from like the medieval days and stuff like that. And interna, internal. This is telling me information about that innermost layer of the blood vessels, okay? Now, that inside of the vessel, this is the part that is exposed to the blood. Now, let's stop and think for a second about blood. Let's go back in our chapters a little bit. Blood has a lot of components to it. If you remember, it's this substance, it's a connective tissue, okay? And think about how it's got all of these red blood cells, white blood cells, proteins, clotting factors, the stuff for fibrin molecules, all you guys know what I mean, right? Okay, so I've got all of this stuff in the blood. You would think that having that mixture, it would actually like clog up, clump up, all this sort of stuff, okay, for the blood. Don't get me wrong, it can, okay? But for the most part, flowing freely. One of the cool things about this inner lining, we're going to see that it's simple squamous epithelium. Do you all happen to remember what that tells us from part 1? What does that tell us about the structure? Simple, 1 layer, squamous, those are the like fried egg cell shapes, okay? We call it, on the inside of the blood vessel, endothelium. Endo to the inside, okay? And we're going to find that it has a basement membrane. Something pretty cool about this inner lining, it is continuous with the inside of the heart. The inside lining of the heart, the endocardium. Well, if you think about what happens with blood, blood has to leave the heart and return. This inner lining of these vessels has the connection for just making it a quote-unquote smooth ride. Does that make sense? For the connection? Now, it is going to be selectively permeable. We're going to find that this inner wall can secrete chemicals for dilation and constriction. Since we're talking about vessels, this means vasodilation, vasoconstriction. Vaso telling us, okay, vessels. The other thing, I think we mentioned this in the chapter on blood. The inner lining has the ability to repel blood cells and platelets to keep clots from forming. Do you guys remember that in the blood chapter? So, if you think about that, okay, this is the reason that this thick connective tissue does not clump up in those vessels. That we continue to have a nice fluid movement. So that internal, the one next to the blood, the other thing about it, it's going to be important in facilitating the flow of blood. The middle layer. So now if I'm looking at that vessel and I have the inner layer that has the connection to the blood, my middle layer going around that vessel, this one is usually thick. So when I'm looking at that blood vessel, if I'm looking at arteries, which are extremely thick, okay, veins, which are not quite as thick, okay, the majority of the thickness is the middle layer. Now, the middle layer is smooth muscle. What does that tell me?
Is it innervated?
It's innervated. And if it's innervated with which nervous system?
The parasympathetic.
The autonomic.
Oh, I mean, sorry.
Well, that's okay, because the parasympathetic and sympathetic is in the autonomic system. So it is innervated with the autonomic nervous system. We're going to find collagen and elastic tissue that can be present. It's going to vary, all right? Mainly because you're looking at, there is a difference between arteries and veins, okay? This structure strengthens these vessels for blood pressure, especially the arteries, because we've talked about that. The arteries are under pressure. And I can't ever say that and not think, have that song playing in my head, okay? And they're pulsatile, meaning those arteries are pulsating with every heartbeat. The veins are not. However, it doesn't mean that we don't have some of the smooth muscle, innervate, all that other stuff that goes with it, because some of the veins do, all right? But pressure very low. Veins, not pulsatile. We're going to find that the middle layer will help to regulate the diameter of the blood vessels. So, if it is innervated and it's smooth muscle, that means we are not controlling it, okay? It's under the control of those parasympathetic, sympathetic divisions, okay? So that means it's going to have to, like, for example, anybody liking the weather we have right now?
I don't mind. I like cold.
Temperature's good.
I like
the
cold.
Okay, well, I'd be fine with temperature staying right in the 60s, 70s all the time, okay? So, right now, you go outside, and what do? This is not good. Y'all know that's not what I'm saying, okay? But you know, this is not good, all right? Got the little stuff coming out of your mouth every time you speak. All right. Because of my body measuring everything, and one of the things I have is temperature control, okay? It's not going to be sending blood to my extremities. It's going to constrict those vessels, okay, and push the blood to my inner cord. I'm not controlling that at all right? That is being done at this point for the regulation of the blood. Does that make sense?
Is it the sympathetic that does the constricting?
Now, we have our parasympathetic and a sympathetic division, all right? We're basing this off of information in our cardiac center, well, actually our primitive region. Even though we're thinking sympathetic, parasympathetic, sympathetic, of course, would dilate and most likely push the heat out, okay? But at this point, we're actually needing to channel it to the core. So it's not parasympathetic that's doing it, it's still sympathetic. We're just having a channel to a different area.
Okay.
Is this also what happens, or is that the same concept behind shunting during massive trauma and blood loss?
Yes, yes, okay, which we're going to actually look at. We're going to actually see that. Now, the external layer, okay, the outer tunic, also known as adventitia. I don't know why. I've never looked, okay. This one, loose connective tissue, it's going to most likely merge with neighboring blood vessels, nerves, and other organs. Now, what it's doing, it helps to anchor our vessels. You would think that with all the tissues we have, that wouldn't necessarily be a problem, okay? But it can be. So the structure to the outside is going to help to anchor the vessel. Now, look what this does, this outer layer. Let me preface it by saying this. Do you guys remember when I talked about the heart and how the heart was tissue itself and needed a blood supply? Okay? The vessels are the same way. Vessels are a tissue themselves. They need a blood supply and a nerve supply. They're going to have it. Okay? So blood vessels, when you look at roughly smaller to the medium to the large, what you're going to see in that vessel is you're going to see a little entry for these vessels. So you're going to find that there will be a passageway for nerves to come into the blood vessel, lymph vessels to be present, and smaller blood vessels. Does that just not sound like, what? Blood vessels to feed the blood vessels?
So do they also get blood from the heart too?
Well, they'll get blood as it circulates through that vessel. And as it pumps, that means there'll be a pump to that particular vessel. And then we'll have to have the vein that'll take it away. So yes, it also operates based on the heartbeat. For the artery that'll feed the vessel, and then the vein will operate just like veins for the vein. Because the vessel itself is tissue and it's working, so we've got to get the blood supply with the nutrients to those cells. As those cells function, they give off waste. We got to pick up the waste and get rid of them. So the blood supply to the blood vessels, so to speak, is termed vasa vasorum. I think in your text there's a picture. I thought it was. Okay. It's not. Sorry, my mistake. But it's really cool. Look it up, and you'll be able to find pictures with a little graphic showing the actual feed into the blood vessel. It's really pretty cool. So it's termed the vasa vasorum, basically to help feed the tissues of the blood vessels.